What is synaptic plasticity, and why is it often called the foundation of learning and memory? To understand how the brain adapts, remembers, and changes, we need to look at how neurons communicate with each other and how those connections evolve over time. Synaptic plasticity refers to the brain's ability to strengthen or weaken synapses, which are the tiny junctions where one neuron communicates with another. Every thought, memory, skill, or habit you have is influenced by how strong or weak these synaptic connections are. The brain is not a fixed machine. It is a constantly changing network, and synaptic plasticity is the reason why. When two neurons frequently activate together, the connection between them becomes stronger. This principle is often summarized as neurons that fire together, wire together. This process is known as long-term potentiation, or LTP. LTP increases the efficiency of signal transmission, making it easier for one neuron to activate another in the future. This mechanism plays a crucial role in learning new information and forming long-lasting memories. On the other hand, synaptic connections can also weaken through a process called long-term depression, or LTD. When neurons are rarely used together, their connection becomes less effective. This is just as important as strengthening synapses, because it allows the brain to remove unnecessary connections, reduce noise, and stay flexible. Without synaptic weakening, the brain would become overloaded with useless information. Synaptic plasticity occurs throughout life, but it is especially powerful during childhood when the brain is rapidly developing. However, adult brains are far from static. Learning a new language, practicing a musical instrument, or even forming new habits all rely on ongoing synaptic changes. Even recovery after brain injury depends heavily on plasticity, as surviving neurons reorganize their connections to compensate for lost functions. At the molecular level, synaptic plasticity involves changes in neurotransmitter release, receptor sensitivity, and even the physical structure of synapses. These microscopic changes add up to large-scale transformations in how the brain processes information. In simple terms, synaptic plasticity is the brain's way of adapting to experience. It allows us to learn from the past, respond to the present, and prepare for the future. Without synaptic plasticity, learning would be impossible, memories would not last, and the brain would lose its remarkable ability to change.